Okay. 3, 2, 3, 2, 8. There we go. Aha. Pendulum question. Fine. Okay, let's have a look. The diagram below shows two spherical masses, big M and small m, suspended on a long thin string of equal length attached to the same point. Mass m has 100 grams and mass small m is 20 grams. It's held with its string taut and with its center 30 centimeters above that of m. M is released, swings, moves, sticks together. Okay, so you got a small mass here of 20 grams. You release it and it swings down and it hits this heavy mass. And then the two of them move off together because they stick then. Okay? So the first question is, what speed will the small mass hit the big mass? So for that I need conservation of energy. The energy at the beginning is only potential. M G H. That will equal the kinetic energy at the end. A half m v squared. So, a little bit of cancelling here. You can cancel out those masses. And I can get V will be 0.6 times 9.81 square root of. So what do we get here for the V? 2.43. Okay. B. What will be the initial speed after the collision? So we have a collision, so now we use conservation of momentum. So that would be m1 u1. Now, because this is heading to the left, maybe I want to say it's minus m1, oh my goodness, m1 u1 plus m2 u2, and then the total mass afterwards is 0.120 v, a different v this time. Momentum before equals momentum afterwards. So just by dividing there by 0.12, that's 0, so that's gone. So what do you get here for this v? 405 meters per second. Okay. Thank you. To the left. What was the loss in kinetic energy?
But you said initial, not final. What would be the initial momentum speed of the two masses?
That's bad grammar on their part. They said the initial horizontal speed after the collision. It's final then, yeah. Now I know why they said initial, because they don't want you thinking too much time has passed and it's swung up to the final, you know. No, I understand what you're saying. The English maybe is a little confusing, but in this formula it's the final. Yeah. Right, how much kinetic energy was lost? Well, let's calculate the kinetic energy at the beginning. That is a half m v squared, which is 2.43, isn't it? And this, the minus doesn't matter too much because the square. So you can tell me that. Joules. Kinetic energy at the end is a half m v squared. And what's this one? Smaller, I hope. 0.01 joules. Okay, so they want the percentage lost. That would be 0.05 over 0.06 times 100%. So what's that, 84%? What percent is this, guys? Come on, you all have calculators, can you tell me? Do you have a calculator?
Tuesday.
Oh yes, it's still not here, right. What is it?
83.
Point.
Like 3.
And lastly, what happened to this kinetic energy?
It's inactive.
Transform.
Yeah, to what?
Potential.
No.
Heat. Sound.
Heat and sound. Okay. Right. What will we do next now when you're ready?
Just go.
Will I zoom out? We'll do, or here, Bella? So 1, 2, 3. Kayhan is here. 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me see. Oh, Dammy. Where is he? Bank trouble? Yeah. Yeah? So when you're ready, what is the question we'll need to see next? What ID number? Which one? 435. No, there's my key.
Yeah, your key is a cannot connect to your laptop.
Really?
Yeah.
That's amazing. Why not?
Because I use the Type C.
Oh, Type C.
This is both.
Yes,
This is a
Type C and
both.
Wow.
This is both USB.
Oh. I've never seen that before.
Oh.
Nice.
Yeah.
Yeah, new technology for me. Nice. So is Type C now standard for laptops?
No, it's like Apple Store.
For the Mac
Ah,
and some new laptop, I was using Type C.
I don't like it, Max. Right, we got that? Thank you, thank you. I'll put that on this laptop. ID number 435, was it, Peter? Oh, sorry, Jason. 435?
Yeah.
Yeah, okay. Right. In a game of 10-pin bowling, a ball of mass 5 kilograms used to knock over pins of mass 500. In one game, the ball has velocity of 10 just before striking a stationary pin. After the collision, it moves in its original direction with a velocity of 8.5. Right, I don't need to do the A part, do I? You know that. What is the velocity of the skill after the collision? Okay, so I'll just draw the picture here. You have the ball and you have the pin, and they both, one is moving to the right and the other is stationary. And then after the collision, this has knocked down and now is moving, and this is moving as well. And I'll call this one V1, and this one here is V2, and this one is U1, and this one is U2. Now let's write down the info. Okay, M1 is 5 times U1, 10, plus M2, which is 0.5, times U2, which is 0. equals m1, which is 5. After the collision, it moves in its original direction with velocity of 8.5. V1 plus m2 v2. Okay, so I should be able to get v2 here, shouldn't I? Huh? It is, hang on, sorry, what am I doing? 10 over 8.5 over 0.5, 5 over 8.5, 5 over 8.5, 10 over 17 meters per second. What is v2? A little bit over half. Do you mind? This part here is gone. I can say, sorry, I'm doing that wrong. For 1.5 times 5, 7.5 over 15, is it? 15 meters per second? Okay. C. Is this elastic or inelastic? Yeah? Elastic or inelastic? Well, the kinetic energy beforehand is, you have it already, a half is it 50?
No.
10 squared, which is 250.
Yes.
The kinetic energy afterwards is a half 15, half
8.5.
oh, it sure is 15. That doesn't seem right. I must have made a mistake.
No, 2 of them.
It's 15.
Oh, that's V2, yeah, sorry, not V1. So V1 is 8.5. A half m V1 squared plus a half m V2 squared. So what do you get for this one?
237.
What is it?
237.
Which is less. So a loss of 13 joules, isn't that right? So that implies inelastic.
So when is it elastic?
Hmm?
When is it elastic?
If there were no loss in kinetic energy. Let me put this on my computer.
Okay.
One sec, folks. Let me just save this. These two, I assume, huh?
Yeah.
Six gigabytes?
Yeah.
Whoa.
So
That's going to take a while to upload. I'll have to leave it overnight. The internet in the office is a little bit faster because we have our own internet connection, you know,
Yeah.
with Virgin Media.
Yeah.
So
no.
the upload speed's a little bit better. It'll take
6 GB.
6 GB will take about
If you
no,
use
it's not
the
that bad.
place,
It'll take about one or 2 hours.
maybe more. I think.
No, not
Just
for
accommodation.
no. Well, in the accommodation, yeah, but not in the office. It should be okay. I'll set it up tonight.
You want to take away the everything?
Oh, you're back, Kay-Han. Oh, I better write down who's missing. Just. Oh no, my pen. Wow, it snapped.
Mm-hmm.
Broke.
Oh,
I got another one.
okay.
Right, write that down. Now. I think that's probably okay, isn't it?
Yeah.
So what was wrong with this, Jason?
No. Just 8. I don't know how to write how to present that.
Wait, it was just A.
Yeah.
And that's the part I didn't do.
Yeah.
Why didn't you say something, man?
I just want to
That
tell.
was just the definition, I think.
Let's just copy the definition from the notes.
States that during a collision.
Oh, Jason. Jason.
Are we going to have the definition of the exam?
Huh?
Are we going to have the definition?
Right, which exam?
With the
Midterm.
midterm or
Let's
final?
start with midterm first.
Well, you know the answer for final because these are all questions from the final. So, Yes, is the answer to that part. Now, will I give you questions in the midterm on the definition? Maybe. Maybe not. Because what I'm going to do, my plan for the midterm, actually I should tell you this now, my plan for the midterm exam is simply to take random homework questions and paste them into a Word document, and there's your exam. Okay? So I do not have the time to imagine and write new questions. I am just going to take random questions from this workbook and make that your exam. So if you can do the workbook questions, then you're fine. Now what I haven't decided on is how many questions to give you and how much time to give you. This is the thing I need to decide. Do I want to make it 1 or 2 hour exam? Don't know.
Depends on you.
It does depend on me.
Yeah.
Just missing Dami, isn't it?
Easy question, please.
Let's make it 1 hour 15 minutes.
No.
1 hour 30.
No, I'm going to make it... I was thinking of making it a 1 hour exam. Like basically, if I make it 2 hours, then I have twice the number of questions.
No.
But
After the break?
1 hour is not right.
I don't know yet. I don't know. I'm going to talk to your chemistry teacher. I don't need to talk to your maths teacher because I know what he's doing. I'm thinking... Oh, I don't know.
So
I'm thinking a 1 hour exam. That's what I'm thinking.
So your
Just
exam.
write 1 and 2 in bulk and then shuffle them and then whichever one you pick. That's
No, I think it's better for you to make it a 1 hour exam. It's just a question of how many questions to give you. So, you know the way each question has marks. Like for example, the one we were just doing, 435, I can see that's a 6 mark question. So because it's a 1 hour exam, well, one class exam, so that's 50 minutes. So I was thinking of making it 50 marks, because it's supposed to take you 1 minute to do 1 mark. So I could do, for example, 10 5-mark questions, or if they're 4-mark questions, I might have a little bit extra. You know, if there's a 6-mark question, then that maybe I'll only have 9 questions. But in total, there'll be 50 marks, I think. Yeah. All right.
So
Now,
when we do the exam,
I don't know. I also have to talk to the maths teacher and the chemistry teacher to see what will be the best day.
okay.
In the same day.
No, I'll try not. We'll try not to have 2 exams on the same day. So, like maybe one day is chemistry, one day is maths, and one
Is
day
it
is
a
physics.
follow this timetable?
Is that? I don't know, to be honest. I'm really bad at what I do. I don't know.
We have 7.
I dislike planning.
We
Huh?
have a lot of physics classes.
We have what?
A lot of physics class.
this week.
Do you? How many?
7.
How the heck did that
And
happen?
then 1 math.
We have 7 physics and 1 maths?
Yeah, that's what
I checked for you.
timetable for.
I know somebody screwed up
You're
there.
cheating the maths teacher.
I am cheating the maths teacher out of maths time. Can you hand that up, please?
Yeah.
Yeah.
There is 2 math.
2 math?
Still,
Yeah,
not enough.
it's 2 math, yeah.
Is this because of that counselling fair?
Yeah.
What's plan for?
We have 7
And students are old,
physics.
but you can.
7 physics.
Yeah, we have to change some of those into maths.
Yeah, that's
You
more
can
than,
like
more than usual.
physics, 4 math.
We have 7 physics and how many maths?
2 math.
You
2
have
maths.
9.
No, I'll change 2 of the physics into 2 maths,
Yeah.
making it 5 and 4.
Which day?
They will let us know now. We're not good at this stuff.
Yeah, exactly.
Tomorrow. You
Bad
have 1
relationship
math,
with the
1
maths
physics.
teacher.
Teacher,
Do you know what I'll do? I'll do something a little bit different this week. I'll just make all the classes at the start of the week physics. Because my physics, I have to get the mechanics finished. So we'll just keep doing mechanics until we're finished, and then we'll switch to maths for the rest of the week.
Yeah.
Okay.
Okay, and then the last maths class, as usual, will be the tutorial then. Okay? Yeah. All right. Thank you. You can pass that back. Okay, let's have a look now at the circular motion. So the circular motion is kind of a big topic. So in my plan, I like to not do two topics this morning. I was planning, as I said last week, to do just one topic in a double class because the circular motion is a big topic. So we'll get started on that. Come on. Sorry. Right.
Oh God. 17 questions.
For circular motion.
Yeah.
Yeah, I told you it's a big topic, didn't I? Right. Physics. Mechanics. Circular motion. Now, it doesn't look like we have much left to do, but actually this is a big topic, and this is a big topic, and this is a small topic. So we should get circular motion done today, then we have another double and a single after that. Alright, let's